All right, you guys, we're going to take a look at 4.7 today, transformation of quadratic graphs. A lot of the stuff we've already talked about, so today is kind of a summary of everything put together. And the big thing we're going to use today or talk about today is vertex form. If you don't have that down in your notes, you probably want to get that down. And actually, I have all the forms here. So standard form, ax squared plus bx plus c. Vertex form is going to be the new one for you today. A parentheses x minus h squared plus k. And then the factored form is a parentheses x minus p times the quantity x minus q. Notice in all three of these forms, they have an a value. I will tell you that across all three forms, those a values are the exact same, okay? So if you have an equation in standard form, if you put it in factored form, your a values will correspond. If you took your equation from standard form and put it in vertex form, your a values would be the exact same, okay? Again, each equation tells you something specific. So vertex form obviously tells you your vertex is at the point hk. That's a good thing. In factored form, our p and q are the solutions or x-intercepts. All right. So they are, important to understand each form because each form is going to tell you something specific. Okay. And then today is all about going in back and forth between the two. So if we go from standard form to factored form, we factor. If we go from either of these forms back to standard form, that's what we call expansion, or FOIL, we'll call expansion, or you FOIL it open, okay? The process moving from standard to vertex form is completing the square, and that's what we talked about 2 days ago in lesson 4.5. All right. One thing to talk about before I move on, sometimes factored form is referred to as intercept form as well. Okay. Depending on your text, worksheet, etc., they may toggle back and forth between the two, but just remember factored form and intercept form are the same thing. All right. So first things first, writing equations in vertex form. Again, it's very similar to the process of completing the square. Okay. What we want to do is we want to find how to factor this expression into a perfect square. So what I'm going to do is I'm going to leave some space. I could move the 4 over like I did with completing the square, but know that you're going to have to move it back anyways because you want y to be by itself, okay? So I've just given myself a little space to work with, and just like before, to create our c value, we want to do half of b, so half of b squared. Half of 10 is 5, 5 squared is 25. Keep in mind, we want to keep our equation balanced. So I could add 25 over to the left-hand side, or I can just add and subtract it from the same side, okay? It's your call. If you wanted to put negative 25 over here, again, like I said before, you're eventually going to have to move it back anyways. So that's why I always do positive and negative on the same side to keep my equation balanced. This piece then factors into x plus 5 squared. Negative 4 and negative 25 is negative 29. And now we have our vertex form, okay? If you were asked for the vertex of this problem, you could state that it is at negative 5, negative 29, all right? When there's an a value out front, it makes things slightly more challenging, okay? Because if you recall with completing the square, what we need to do is get rid of that. So what I'm going to do is I'm going to factor that number out of just the first portion of my expression, okay? So if you notice, we have the exact same thing. I just changed how it looks. So I didn't divide, all right? Because if I divide everything by 2, I'm going to have to eventually multiply everything by 2 to get y back by itself, okay? So I'm going to leave everything over on the right-hand side. All I did was factor out 2 from my variable expressions, and I left the 17 alone outside the parentheses. So now, just like before, I'm going to take half of b squared, which is going to be 9. Okay. Now, just like before, if I add 9 to my equation, typically you'd want to subtract 9 from the same side. The one catch here is this isn't a 9. Keep in mind, this is an 18 because we have that 2 out front. 2 times 9 is 18. So if I am adding 18, I actually want to subtract 18 from this side. That way we'll keep my equation balanced. And then just like before, we then want to factor our expression into that perfect square. So we wind up with 2 times the quantity of x minus 3 squared. Negative 17 minus 18 is negative 1. So the vertex of this problem is 3, negative 1. H and K keep coming back. Hopefully you kind of realize that and see that. But that concept's going to keep repeating itself throughout the year. So whenever we see H and K, we always know that's the vertex of the graph. Again, on these questions, we're using the completing the square process. If you want to move stuff over to the left-hand side and then move it back, you're welcome to. Otherwise, you can do exactly what I did. And if you add 25, you can subtract 25 on the same side to keep your equation balanced. Remember, in a situation where there was an A, when you put a number like 9 here, it's not a 9, it's actually an 18. So you'd want to subtract 18 to keep your equation balanced. All right, continuing on, you'll have some examples like these. So we know from, up above, we have our vertex form, all right, our standard form. So if we were trying to figure this out, I know my H and K are negative 1, 2. So minus a negative 1 is going to be plus 1. And I know my K value is negative 2. The question is, how does this help? Well, keep in mind, that's an X and a Y. So if I plug in an X and a Y, notice A is the only thing I have left. So I should be able to solve. Negative 3 squared is 9. So I have 9A minus 2. 9A is 15, which means A, after I reduce, is going to be 5/3. Okay? So we plugged in our vertex, we plugged in our points for X and Y, we solved for A, and now we have our equation, 5/3, and then we can copy what we had from up above. So our H value is negative 1, so minus negative 1 is plus 1, and our K value is minus 2. All right, so those ones should be pretty straightforward. As we continue on, again, looking at graphs, we're just going to go over a few characteristics of things. Keep in mind, we've talked about all this before, so it shouldn't be new, all right? When we look at H values, remember that's our shift left and right. So our parent function here is in blue. And then when our graph shifts right 4, that actually corresponds to a negative 4. When our graph shifts left 2, that corresponds to plus 2. Because remember, in our vertex form, H is actually a negative 2, which shows on our graph. Okay. Remember, our K value is that up and down movement. So our parent function, again, is in blue. If we move our graph up 4, that corresponds to that red value. If our K value is negative 5, your graph moves down 5. The last kind of summary of how these values impact things are the A value. Again, A is true across all 3 forms. So we have our parent function in blue. First off, if it's positive, it opens up. If it's negative, it opens down. We should already know that. If it's a number bigger than 1, like 3x squared, it's going to be a much narrower parabola. If we have a number that's less than 1, or a fraction of 1, it's going to be a much wider parabola. And most of you probably recognize those when we were discussing section 4.1. It just never dawned on you at that time that it was related to H, K, and A. But that's kind of a summary of the information we've already talked about this chapter. As we go into things down here, furthermore, looking at more specifically vertex form, if our H is less than 0, our graph moves left. If it's greater than 0, it's going to move to the right. All right. If our K value is negative, it's going to move down. If our K value is positive, it moves up. If our A value is less than 1, it opens down. If our A value is greater than 0, it moves up. And then these last two, what we'll call this, if it's bigger than 1, it's a stretch vertical, or if you said narrower, that's fine. If you want to say shrink vertically, or maybe flatter, it's kind of like somebody sat on your parabola and made it wider, that would be acceptable to say there as well. All right. The last thing here, graphing in vertex form, super easy to kind of think about. All right, we know our vertex is at -3, -4. We know our A value is 2, which means our parabola is going to open up. So then what we can do is go right to our graph. We have -3, -4 is the vertex. And then what I would do, we have our axis of symmetry, obviously goes right through the vertex. The easiest thing to do is probably just plug in a 0 to figure out that y-intercept. So we have 3 squared is 9, 9 times 2 is 18, 18 minus 4 is 14. Notice the y-intercept is going to be way off the graph there. So let's pick another point to kind of copy over. So if I pick a -2, we get -2 plus 3 is 1, 1 squared is 1, 1 times 2 is 2, 2 minus 4 is -2. So then what I can do is copy that point over my axis of symmetry and graph my parabola. So vertex form is actually really conducive to help graph things. You may have seen a problem in vertex form but didn't know it is vertex form. But yeah, all you need to do is find the vertex, find one point on your axis of symmetry. We can copy it over and we're good to go. Okay. Homework's listed on the bottom of the page. Make sure you know how to find your vertex, axis of symmetry, domain, range, x and y intercepts on every question, because that's what you're going to have to do on the quiz. Please make sure you know how to do it in every form, whether it be standard vertex or factored form. All the forms, you need to be able to find those pieces of information. That is super important. Okay. If you have any questions for me, let me know. Otherwise, best of luck on this assignment. I bid you all a farewell.